Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about single phase full wave rectifier using RLE load. Friends, as we all discussed earlier, how RL load affects the output voltage and output current in case of a rectifier using thyristor. So friends, let's talk about if a RLE load is connected, then what happens to the output voltage and the output current, and we will be deriving some mathematical expression as well. So friends, as you all can see in this circuit, I have connected a sine wave source or a AC source to an RLE load through a thyristor which is called T1. Let's say T1 be the thyristor. Let VT be the voltage across the thyristor, IS be the source current, and I naught be the output current, and V naught is the voltage across the output, L is the inductance, R is the resistance, and E is the EMF, or E is the battery that is connected as a load. Now friends, let's analyze the waveform. So Vs is the sinusoidal wave, and let Ig be the gate current which is applied across the gate terminal, or whenever the gate terminal of the thyristor is applied with an external voltage supply, then Ig be the amount of current that flows which triggers the thyristor. During the thyristor, because whenever we apply a gate current to the gate terminal of a thyristor, it gets triggered, and because of that the thyristor conducts. So let's say alpha is the angle of conduction where the thyristor is triggered. Now we'll not be getting any output voltage, but initially the output voltage will be equal to E. Whenever omega t varies from 0 to alpha. So we will be getting a voltage E initially, then the same waveform follows as we discussed earlier. So we can see the output waveform until the next angle, and as a thyristor blocks the negative sine wave or the negative AC supply or the negative half cycle of the AC supply, again we will be getting an E voltage which will be seen across the output. Again the same process continues, and for the output current also the same process continues. The waveform of the output current would be somehow like this. Whenever there is no thyristor conduction, the current will be 0 from 0 to alpha. At alpha, whenever the thyristor started conducting, we can clearly see the output current, and for the negative half cycle it will not be getting conducted, and the same process goes on. Now friends, let's do some mathematical calculations. So friends, as we all know, Is is equal to Is1 plus Is2. So the entire source current will be equal to the steady state 1 current plus steady state 2 current. So Is1 is equal to Vm by Z, Is1 equal to Vm by the impedance sine omega t minus phi. Now because of the DC counter EMF, we get Is2 is equal to negative E divided by R. Now friends, the transient current, as we already explained earlier, which will be equal to A into epsilon minus RT by L. Now the total current in the circuit will be given by I is equal to Is1 plus Is2 plus IT. That will be equal to hence I is equal to, by solving this equation we get I is equal to Vm by Z So that will be the final expression for the total current. Now friends, let's talk about different conditions and different consequences. So friends, let's consider some conditions and find the value of the constant A which we used in the earlier equation, and finally we will be finding the value of the output current. So friends, at omega t is equal to alpha, obviously the output current equal to 0, as we all saw in the graph. Now, if we put the same condition in the earlier equation, we get the value of A, which is equal to now if we put the value of A in the earlier equation, we can easily find the value of the output current, which will be equal to I naught is equal to minus E divided by R. So this will be the final value of the output current. Now let's talk about the output voltage, friends. So before we talk about the output voltage, let's find what will be the average value of the output current. So friends, let's talk about the average value of the output current, which is given by I naught is equal to 1 by 2 pi R, which is the average cycle, and R is the resistance. I'm just simply dividing the output voltage with the resistance. Integration alpha to beta Vm sine omega t minus E d omega t. Now friends, if we solve this, we get 1 by 2 pi R Vm cos alpha minus cos beta minus E into beta minus alpha. So friends, if we talk about the conduction angle now, what happens during the conduction angle? Now, the conduction angle is equal to beta minus alpha. Now, if we have to find the value of beta, if we put the same value in the earlier equation, we get so that will be the final expression for the output current. So I naught is equal to 1 by 2 pi R into Vm cos alpha minus cos alpha plus small v, which we consider as conduction angle, minus EV. So friends, let's talk about the power loss. Now, before we calculate the power loss, let's calculate what will be the final value of the output voltage. As we all know, friends, so that will be the value of the output voltage, where E is the load battery which is connected, I naught is the output current, and R is the resistance, which is equal to so V naught equal to E plus I naught into R, which is equal to Vm by 2 pi into cos alpha minus cos theta 1 plus E by 2 into 1 plus theta 1 plus alpha divided by pi. Now friends, let's calculate the power. So the power delivered will be equal to, now this will be the final value of the power delivered to the load. Now friends, let's talk about the power factor, which is given by so friends, here this I naught and this I naught both are different. This is also different than this. So we see this is IOR is the current flowing through the resistor, which includes or which consequences a resistive power loss, and I naught is the normal output current. In the same way, here I'm trying to differentiate IOR and IO in different manner, and here in this equation this becomes IOR again. So P is equal to I square OR into R plus I naught into E, and the power factor becomes IOR square into R plus I naught into E divided by Vs into IOR. So thank you so much friends for watching this video. Please subscribe to Ekeeda and stay tuned to the Ekeeda. Thank you so much.